Hey everybody, this is Larry. This is day 25 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get started. A minimum cost for tickets. In the country probably for train travel, you're planning some train trip more than 1 year in advance. Okay. Um. Hmm. Okay. So you basically have all of these criteria you want to meet, and you want to get the cheapest cost. Um. Yeah, I mean, this is clearly dynamic programming. You could do it either top down or bottoms up. Um, I think you can do it in a linear way. Um, I mean, what I would do is maybe just think about which one is this 30 day again? Okay. Just basically, what is the cheapest cost that I mean, I think it's just all about setting up the array, right? So, and how you want to do it. I could do it top downs first, but maybe I'm still just trying to figure out which way to do it. But basically, the idea is that it's just trying to figure out a little bit about the data structure on how to represent this. I'm thinking in between a Boolean array of 365 or just, given this, and I'm trying to think about which one is easier. Um, hmm. But yeah, I mean, I think I would define the array as the dynamic programming array, the state as the cheapest. So for dynamic program problems, the thing that I would like to do is, even though if you have enough practice, you could kind of hand wave this, but just to be precise, on day X, if we buy this ticket of a 1 day ticket, a 7 day ticket, or a 30 day ticket, what is the cheapest cost with that end in mind, right? So yeah, so I think that's the way I'm going to do it. And let's do it top down because I think I'm pretty okay for now. And let's go min cost. How do we want to do it? Do we want to go index or just call day? Maybe. We'll do some maps. Let's just call it index, even though the day would be the same as the index. And then that should be mostly it. These two are correlated kind of. It's just that it's easier for me to write. Because I think we'll just cache on day, right? But yeah. So basically, I'm gonna write this down without the memo first, and then we'll see how it goes. So basically, if day is so basically, what is our function? Is the minimum cost to cover up to day input day, right? So that's kind of the question that we have for this dynamic programming. So now if day is greater than the last the last day, then we can return 0. Otherwise, what happens, right? So now, yeah, maybe this is a little bit weird. Actually, maybe what I want is actually a Boolean thing. Yeah, okay. So yeah, must buy tickets day or something. Must buy is equal to force times 365, and then now for day and days, must buy of day is equal to true. I'm just checking to see if it's 0 indexed or 1 indexed. Seems like it's 1 indexed, so let's do day minus 1 is equal to true. So then now we go if day is greater than 365, we just return 0, or equal to 365 actually. And if we have to buy for this day, then, or if not, if we don't need to buy a ticket for this day, then we just return the min cost of buying it for the day plus 1, right? For tomorrow, because if you don't need to buy for today, then you don't really need to buy it. Like you could, in a way, it's sort of greedy in that you want to buy the latest day, right? And if you don't need it for this day, you don't need it for this day. And then now we check else. So in this case, now we have to buy it for today. So then we get the cost of, so there are only 3 cases, right? Buy 1 day is equal to min cost of day plus 1 plus costs of 0, which is the day 1 day pass. Actually, I guess that's it, right? And by, was it 7? Yeah, by 7 day is equal to min cost day plus 7 plus cost of 1. And then by 30 days, I think. Yeah. By 30 day pass is equal to this plus 30 plus cost of 2. And then now we just return the min of all those things. And that's pretty much it. Min cost from day 0. And you could do it backwards, forwards. In this case, it's symmetric. It's not always going to be symmetric, but you just have to make sure that whatever you're doing is symmetric. And that means going forward and backward is the same. Okay, so that looks good. Though I don't know why it didn't give me an answer for the second one. Let me try running it again. Maybe I didn't click it early enough. Oh, that's not the second one. That's just the cost input. Whoops. Okay. Yeah, and again, the thing that I would worry about right now is just timing out. Or the thing that I'm caring about right now is the running time. Oh, sorry, the correctness. The running time, we know it's going to be a little bit slow, so yeah, we don't have to worry about it. And then now we just have to think about how to cache this, right? Well, there are only about 365, give or take a couple possible inputs to min cost. So then we could actually just store that, right? So let's just do cache is equal to I don't know, some value times 365, and then has cache is equal to force times 365. So if it's greater than 365, we just do that base value. If has cache of day, we return cache of day. Otherwise, and then at the very end, we cache this thing. And then we cache of day has cache of day is equal to true. So we try again real quick. Looks okay. I think a thing that you can do to check your caching works is just having a big example, right? Which, you know, I don't know. I think I would just have a big example and then run it just real quick. I mean, I would probably have a bigger example, but I'm just a little bit lazy on the typing. It looks okay, so I'm going to submit and then see how it goes. Cool. Yeah, I mean, I think I spent a little bit of time in the beginning just try to formulate how I exactly want it. Definitely take the time to do it before you jump into code, because once you jump into code, like the coding for dynamic programming or memorization is generally pretty straightforward. You just have to ask the right questions, right? And in a way, I you know, if you saw that in my mind I fluctuate about a couple of times, and I even think about whether to have, you know, which one to buy on it here. But this seems okay. And again, because as I said, it is symmetric, you can actually reduce this to, like, you know, a similar thing where you start on day 365 and you do day -1, right? And from that, you could actually construct the bottoms up dynamic programming, because this is your recurrence, right? Your recurrence is f of, I mean, this is your recurrence, right? Min cost of day is just equal to these three, which you can do in the linear time as you progress, looking backwards. So yeah, so that's what I have for this problem. So this is depending on how you want to call it. It's O of n or O of 1 because it's always going to be at most 365 time, and because that's the number of possible inputs. The min cost is just 365. Depending on how you want to define it precisely, but that's fine. And each of them will do O of 1 cost, so it's going to be linear slash O of 365 or whatever. Yeah. And in terms of space, of course, it's also going to be O of 365. I know that that's not real big O, but like I said, it depends how you want to define n and 365 and so forth. Yeah, that's all I have for this problem. Hit the like button and subscribe button. Let me know what you think. Join me on Discord, ask questions, and I will talk to y'all later. Bye bye.